Hey there. So I'm going to do the next section for big ideas, and it's the distribution of data. I'm going to share my screen so you can see what I'm looking at. We are going to do this section. It's shapes of distribution 10.3. Okay, so the big ideas shows what does it mean for a data set to have a skewed distribution. Okay, so we need to look at a couple examples to see what that would look like. So here is an example right here of skewed data. So you can see this is skewed data. And what you see is the line comes up and it's heavy on one side, and then it kind of slants over here, and it makes what they call the tail. So right here, when data has a long tail on one side or the other, and it's not symmetrical. So when we look at symmetrical, it means it's even. See how that's like the same amount on this side, the same amount on this side. So the left and the right are very even. That's what makes that symmetrical. So when we look at the next one right here, they take the data and it says make a dot plot of the data, and they have all those numbers, and then they turn this into the dot plot. So if I were to draw it up like this, it actually looks pretty even. And that word, when something is even on both sides, is symmetric. So this is symmetrical. And the way they worded the answer is the peak of distribution is at 30. There's your peak, the highest part. There's the same number of values on each side of the peak. So it is symmetric. Okay, so now we're going to go to, let's go example 1. So can you tell the way this looks? Is this going to have a tail? I think it's going to have a tail, kind of like that example I showed you on this one, where it has the tail. So we look at the information. Most of the data are on the left, and the tail extends to the right. So you can see the tail's on the right side. So the distribution is skewed right. So the way you get your answer here is if the tail is on the right, it's skewed right. If the tail were to be reversed on the left, it would be skewed left. So this one right here, the pass is thrown. They have the information going up, and they're actually saying it's symmetric. You can see it doesn't have to be perfect as far as the way it looks. Like this one's a little bit higher than this one, and then this one's a little lower than that one, and this one's a little lower than that one. They say the left side of the graph is approximately means about a mirror image of the right side of the graph. So the distribution is symmetric. Okay, so let's go to example 2. They call these frequency tables. It shows the ages of people watching a comedy in a theater. So the ages 10 to 13, there's 1, 14 to 17, 3, and so on. So when we actually look at the data, can you tell if it's going to be skewed left or skewed right or symmetric? They're saying most of the data are on the right and the tail extends to the left. So the distribution is skewed left. And this one here, can you see the tail is on the right? So it's going to be skewed right. And then which movie has the older audience? It says the intervals, those are the different stages. This is an interval right here. The intervals on the histogram, remember that's a histogram, are the same. Most of the data for the animated movies are on the left, while most of the data for the comedy are on the right. So comedy has the older audience. And that should give us a good idea now of what this section looks like. Let me know if you have any specific questions, and I'll do them. Other than that, do your best on the big ideas. Thanks. Stop recording. Okay, bye.